All right, I'm Dan Reichert. I'm director of the Skynet Robotic Telescope Network, and we're doing a series of video tutorials on how to use Skynet and how to use Afterglow. In this first tutorial, we're going to figure out how to put an observation on one of our optical telescopes. So let me slide this window over here, and I'm going to share my screen. Okay, what you should be looking at right now is our main website, skynet.unc.edu. Many different things you can do here, but let's stick to the task at hand, and that is putting an observation on the system, an optical observation. So go to My Observatory, go to Optical Observing, and this will take you to your observation list. These are all the observations you've put in and their current status. You can see I have a very long list going many pages because I've been doing this for a while. You can see some of my recent exposures as well. Anyway, if it's your first time here, you don't have anything in your list yet, but let's change that. So let's go to Add New Observation. So click right here. And before I describe this page, let me just point out the list up here. We call these breadcrumbs. This shows you where you're at in the process of putting in an observation. We're currently on the target selection page, which means we're going to pick what object we want to look at. Then we're going to pick what filters we want to observe in. Do we want red light or green light or a specific astronomical filter or a combination of them? Then we're going to pick our telescopes. Again, you can pick a single telescope or you can pick many telescopes. First telescope available will execute the job for you. And then you're going to put in your exposures. Maybe you want 5 exposures in this filter, each of a certain duration, and 3 exposures in a different filter, each of a different duration. So we do all that on that page. Then we're going to review it and submit it. Okay, so let's start on the target page here. And we got to pick something to observe. There's a couple different ways you can do it. If you don't know what you're going to observe, you're just here for the first time poking around, I recommend using SkyViewer, this graphical interface over here. Now, if I hit the little clock symbol, it takes me to the current time, and right now it's daytime when I'm recording this, and so the sun is up and I can't see anything. I could advance the time by moving forward a couple of hours. You can also move minutes or days or months, up to you, but hours is pretty useful. Or I can go straight to sunset. And this is what the sky is going to look like when the sun sets at Sarajevo Inter-American Observatory. It's one of our many observatories. You can see there's a long list here. And it doesn't really matter which one you pick here. You're not picking your telescope at this point. You're just picking what view of the sky you want. For example, if I change to, Moorhead, that's a northern hemisphere telescope. In fact, it's right over my head where I'm recording. So we have a view of the northern sky. If I go back to Sarajevo, which is our primary observatory in the south, we can see we're back in the southern sky. Again, we're just displaying a particular view of the sky for us to poke around and explore. And, well, let's poke around. Let's pick something. I just clicked on M15. That's a globular cluster, and it loads in an archival image. This wasn't taken by Skynet. This is the Digitized Sky Survey. It's a survey of the sky that was done decades ago. And as you click on different parts of the sky, we just pull up that part of the sky so you have an idea of what you'll be looking at, what you'll be taking a picture of. There's kind of just a field of stars. There's a bright star there, another random field of stars. These Messier objects, the ones with the M, these are kind of common big bright objects. A lot of globular clusters. Maybe if I keep poking around, I think I did that one already. Oh, there's a galaxy, Southern Pinwheel Galaxy. So they're galaxies, they're nebulae, globular clusters. And you can type in other things. Maybe you know a nebula you want to look at, such as the Tarantula Nebula. It's a good Southern Hemisphere object because it's always up at night. In fact, there it is. It's not a Messier object, so it wasn't listed, but by typing it in, here you can see the preview, and also it shows you where it is in the sky. Now, if you pick a planet, again, we can do this by typing something in. or by finding it in Sky Viewer. So I picked Jupiter, and that's right here. It's kind of busy in that part of the sky. I'll zoom in here. I have capability of zooming in and back out and picking different objects. Like we picked Jupiter. Over here is Saturn. I could switch to that. For both of those, you saw that it just brought up a field of stars, not a picture of Jupiter or Saturn. That's because the planets, they move around the sky. When the DSS was acquired, again, decades ago, Jupiter, Saturn, the moon, if you select the moon, you can do that right like this. It wasn't in that part of the sky, and so it's not going to be in the archival image. All right, let's go with Jupiter. Okay. So next part, down here, you get to name your observation. I can call it Jupiter. I can call it Jupiter demo, whatever you want, and you give it a custom name. You don't have to type in the coordinates. It looks up the coordinates, and that's the nice thing about the Sky Viewer or the keyword lookup. It will find the coordinates for you. You don't need to know that stuff. And with things like planets that move around the sky, it will update those coordinates before it actually dispatches the observation to the telescope. Because, what if, it's cloudy or the telescopes are busy and it can't get around to it for a day or two? Well, Jupiter's moved, and so it will pick new coordinates. Now, these next three boxes are really kind of important. And when you first use the system, it will come up with various default values. I'm going to tell you what I think you should put in here for this laboratory course. So the first thing is the max sun elevation. You want to observe when the sun is not just below the horizon, but sufficiently below the horizon. If the sun's 1 degree below the horizon, that's not good enough. The sky's still really bright. I recommend you use -12. The sky's getting sufficiently dark, at least for educational work. Now the pros, they wait till the sun is at -18 or below. And you could do that if you want, though the telescopes tend to get kind of busy then, because all the pros are using them then as well. So one strategy is to use -12, and that's twilight essentially, and you'll get observations that are just fine, particularly these big bright objects like planets and globular clusters. -12 is dark enough. Again, you can use -18, but the telescopes tend to get busy then. Now the next one is your target elevation. And I believe the default is 30. That means the target is 30 degrees up in the sky before it will be dispatched, before it will be dispatched to a telescope. Now for the labs, I recommend lowering that a little bit to about 20 degrees. It just makes it, it gives you a greater chance of getting some borderline objects. You don't want to go too low though. If you're observing right over the horizon, you're looking through a whole bunch of atmosphere and there are a lot of clouds down there. The mounts are not well calibrated down there, so you might miss your target. So I recommend using 20 degrees. You can go up to 30, but after that, there's really no difference. And then there's the minimum number of hours visible. If your target's only visible for like a minute, it's probably not even worth trying because the odds are the telescopes are going to be busy doing something else during that minute. I recommend for the labs half an hour, so 0.5 hours. So it needs to be up for at least half an hour, and then it will dispatch it. If it's going to be above your minimum target elevation for less than that time, it won't bother. Okay, so those are good defaults, -12, 20, and 0.5. And there's a reminder in the lab as well for you to switch to those values. Down here we have some advanced settings, pointing offsets, dithering. That's stuff more for professionals. So we're going to close that down and just take a look at the air mass chart. Now this is really important. This tells you if your observation is observable. Sometimes it won't be. And sometimes during the year, Jupiter will be too close to the sun and you can't observe it. And if your observation is not observable, you probably shouldn't put the observation in. You should pick some other target. Now for Jupiter here, this is the next 24 hours. And this gray line is that 20-degree line. Here we're looking at how high up in the sky is your target. Here it is in elevations. Here it is in air mass. It's essentially how many atmospheres you're looking through. If you're looking straight up, that's one atmosphere. The farther down you go, the more atmospheres you're looking through. The more difficult the observation becomes, the blurrier the object likely will be. Anyway, let me just change this again. You can watch the gray line move. If I set that to 30, the gray line moved up. Oh, I hit enter. It took me to the next page. So I'll just come back here. Hide the advanced settings. Anyway, so I moved it up to 30, and you can see that a lot of these observatories, Jupiter never gets high enough in the sky during the nighttime. But if I lower it down to 20, just click off the box, and it lowers it. And maybe I can pick up a few other observatories, but just barely. Anyway, there are two observatories here. This actually may be a double line. No, two observatories. We've got the Prompt Observatory in Chile. That's right here. And this actually is a double line right here. So this is Chile. Right now it's daytime in Chile, but in about 7 hours it will be observable in Chile for 2 or 3 hours or so, and then it's going to set. It's going to get too low to observe. And then the next chance here is about 19 hours from now, and this is when Australia enters nighttime. And we currently have two sites there, the Prompt MO site and the RCOP site. So there are actually two lines here. Anyway, as long as it's observable at some observatory over the next 24 hours, you can proceed to the next page. Okay, next we're going to save and choose our filters. So we saved our target, now we're going to choose our filters. There are all sorts of different filter options. I'm currently set to high through. Let me close that out for a second and show you some of the different options. I have this accordion-like structure here. So there are all sorts of different filter sets. A common one is Johnson-Cousins, UBVRI. So U is kind of on the ultraviolet side. It's still visible light, but more towards the ultraviolet. I is more on the infrared side, still in the visible band, but more towards the infrared. And we got blue and red, and V is the middle of the visible band, so kind of a greenish filter. There's another set, SDSS, that some of the pros like to use, UGRIZ. It's kind of the same deal, different bands going from the blue side to the red side. We also have some astrophotography filters. They're just called red, green, blue, and some other ones as well. Narrowband, these focus in on particular element lines like H alpha, sulfur 2, oxygen 3, which is twice ionized oxygen. And then we have these kind of generic filters. They're catch-alls, and we'll make use in this lab of high through a lot. High through means I'm using either an open or a clear or a luminance. These are filters that let a whole bunch of light through. So if you're looking at something faint, high through is a good filter to go with. If you're looking at something bright, you may want to do low through. So these are filters like narrowband filters or U-band filters, which are near the ultraviolet. Not a lot of light gets through. Or you can just pick it specifically. We're looking at Jupiter. U is a good filter for Jupiter. Jupiter is super, super bright. So we want to pick some kind of filter that does not let a lot of light through. Now I can see when I clicked U, some of my available telescopes disappeared because not all telescopes have a U-band filter. Maybe I'm going to pick U and B, just so I have two options. Okay, so those are the filters I'm going to go with. Now, in the lab, as you're observing planets and moons and different things, it often recommends what filter to use. So pay attention to the lab for those kinds of observations. Okay, saving and continuing. This takes us to telescope selection. So this is all the observatories that I have time on that also can observe this target and also has the filters that we selected, U-band and B-band. Okay? Now, and over here you have a list of different time accounts. And most of you probably only have one time account. But if you're a more advanced user, you may have different time accounts. Different people may have given you access to the system. Now let's open up some of these here. So Cerro Tololo, this is our primary site. And at Cerro Tololo, prompt 5 and prompt 6 have the filters, can observe the target. I can select more telescopes, less telescopes. DSO, this is in North Carolina. This one's in Utah. I've never actually used that telescope. And this one's in Australia. So if you want, you can select all the telescopes. In fact, you can select all the telescopes by clicking on the orange dot. Well, that will select all the telescopes in any particular time account that you happen to have. This one here includes all the telescopes. Now for the labs, what I recommend doing is limiting yourself to the prompt telescopes, particularly if you have a lot of time before the due date. Those are the telescopes that are online most often. They tend to be at better sites, so you're going to get better images. So I'm going to deselect some of these other telescopes, but prompt MO, that's in Australia. These prompt telescopes in Chile. You can use the 1 meter if you want as well, but I'm going to deselect that. Okay, so anything labeled prompt is a good bet. And I would start with just those. Now, if you're getting close to the due date and you're desperate for images, just select everything. And what comes back may be high quality, may be lesser quality, but at least you get something back. Okay, I've selected my telescope, so I'm going to save and continue. So now we're designing our exposures. In Skynet's a really heterogeneous system. We have a whole bunch of very different telescopes. And we don't want to, for Jupiter here, you may want a certain amount of exposure time on one telescope, but the next telescope may be far less efficient. Maybe it's a lot smaller, or it's at a lesser site, and so you need a longer duration to get the same quality image. Or maybe it's a much bigger telescope, and so you want a shorter duration. And it'd be a pain in the neck to have to design this separately for every single telescope you selected. So the way we get around this is you pick a design telescope. Up here under choose exposure efficiency, you're going to pick a design telescope, and I recommend that you pick the generic 16-inch. It happens to be the same as the Prompt 5 telescope. So either the generic 16 back illuminated CCD, that's kind of our default system at a quality site like Ceratololo, or just pick the Prompt 5 telescope if it's one of your options. Design it for this, and then Skynet will modify the exposure times for different things. So suppose we want maybe 2 U-band exposures, we can add a row, and maybe we want 2 B-band exposures. Now Jupiter, these exposures will be taken back to back, so both of these exposures will look the same, so might as well only select one. 1 U-band, 1 B-band. Otherwise, you just get 2 images of essentially the same thing. And then you pick your duration. And maybe I'm going to pick, for Jupiter, something really short. 0.03 is kind of the minimum. And so I'll do the same thing in B-band. And you'll see for Prompt 5, it's 0.03. But if I go to Prompt 6 isn't quite as good as Prompt 5, so it's going to do a slightly longer observation, 0.05 seconds. Prompt MO, it's going to do 0.04. And so it's going to modify these things for you. Now, if you're observing something like a Messier object, like a nebula or a globular cluster or a galaxy, you're probably doing 40-second or 80-second exposures, something like that. And sometimes on your design telescope, you may say, okay, 80 seconds on the design telescope. And on some of these other telescopes, that may correspond to a longer amount of time and maybe a too long amount of time. Each telescope has a maximum exposure that's permissible because the mount is only so good. The mount tracks the object in the sky and can do it well for a short period of time, but not a really long period of time. And so some of these telescopes may drop out. If I pick 40 seconds on Prompt 5, on some other low quality telescope, that may be 500 seconds. And that's too long for its mount to track reliably. And so it will go pink. It just means the observation won't go through on that telescope, but it will still go through on the other ones. Okay. Time account. If you have different time accounts, you'll select which one will be charged here. These are advanced options. we don't need to deal with that in this video, though we'll come back and talk about them in other videos. And then just save and continue. And this is your checkout screen. It's basically everything that you've selected, your observation name, your target, sun elevation angle, minimum target elevation, the different telescopes that you selected as acceptable, and the first telescope that's available will carry out the job. So select as many of the prompts as you can. Here's a list of your filters and exposures, how many and the durations, and what it's going to cost us. This was 2 really short exposures, and so we're being charged 2 credits. It always charges at least a credit, but basically on prompt 5, 1 credit is 1 second. So on the generic telescope, 1 credit is 1 second. A low efficiency telescope, it's fewer credits per second, but it's going to take more seconds to actually carry out the same quality exposure. Okay, we're going to submit. This brings you back to your observation list, and you can see I now have a new observation in the system, Jupiter demo, and it's active. As soon as one of those telescopes is available, it will carry out those 2 observations for me. Okay, that's the end of our first video. Hopefully that was useful and can get you started.